In this practice session, we will do a couple of more questions for arithmetic series. First question is, if S2, S3 and S5 are sum of 2n, 3n and 5n terms of an arithmetic progression, show that S5 is equal to 5 times S3 minus S2. Now S2 is sum of 2n terms, so since S2 is sum of 2n terms, so S2 will be equal to 2n by 2 into 2a plus 2n minus 1 into d, where it is assumed that a is the first term of the series, d is the common difference, and the number of terms is 2n. So let us write this as equation number 1. And similarly, we can define S3, which is sum of 3n terms. Therefore, it must be equal to 3n by 2 into 2a plus 3n minus 1 into d. Let us call this as relation 2. And now S5 is sum of 5n terms. So S5 would be equal to 5n by 2 into 2a plus 5n minus 1 into d. And let us call this as third relation. By the given condition, the right hand side is equal to right hand side is equal to 5 times S3 minus S2, that is S3 minus S2. Therefore, we will subtract 1 from 2. So we will have 5 into S3 is 3n by 2 into 2a plus 3n minus 1 d minus 2n by 2 into 2a plus 2n minus 1 into d. You will close this bracket and then you will close this bigger bracket as well. If we take n by 2 common from both parts of the expression, this will give us 5n by 2 outside, and inside we'll have 3 times 2a plus 3n d minus d minus 2 times 2a plus 2n d minus d. And let us close the bigger bracket. And now what we'll have is 5n by 2 into, this would be 6a plus 9nd minus 3d, and if we multiply minus 2 inside as well, this will become minus 4a minus 4nd and plus 2d plus 2d. That's the simplified form. And now we have 5n by 2 And if we subtract 4a from 6a, this will give us 2a plus 9nd minus 4nd will give us 5nd and minus 3d and plus 2d at the end, that is d, that will give us minus d. So this way what we get is equal to 5n by 2 into 2a plus, if we take d common, this will give us 5n minus 1d, and which is by definition value of S5, which is S5. Thus the relation, this is equal to left hand side, and we have S5 is equal to 5 times S3 minus S2. This relation is proved now. Now the next question is obtain the sum of all integers in the first 1000 integers which are neither divisible by 2 nor by 5. So let us write down those integers. Question number 2. All integers in first 1000 integers which are neither divisible by 2 nor by 5 are here 1 plus 3 plus 7 plus 9. So these are 4 in first 10. Let's write them down together. Plus 11 plus 13 plus 17 plus 19. Those are the next 4. And this way, if we continue, what we have is 991, 993 plus 997, 999. These are the integers, and if we add them up, this will become 20 plus 60 plus so on. And if we add 999, those numbers, this will become 3980. 3980. First we will find how many terms are in this arithmetic progression. First we will find number of terms in this series, AP. So in which the first term is 20, the common difference is 40, the nth term an is equal to 3980, and n is not known, that we will find using an is equal to a plus n minus 1 into d. An is 3980 is equal to 20 plus n minus 1, and d is 40 here. This means we have 3980 is equal to 20 plus 40n minus 40. So this should give us 3980 is equal to 40n minus 20, and if we add 20 on both sides, that will be 4000 is equal to 40n. Dividing both sides by 40, that will give us n is equal to 4000 divided by 40. This is equal to 100. Once we have found the number of terms, now we can find the sum of terms. Now we can find sum of the terms, because what was required of us is that find the sum of all such numbers. Thus, this will be 20 plus 60 plus so on, and the last term was, what was the last term? That was 3980. 3980 are up to 100 terms. 100 terms we are required to find the sum. So A is equal to 20, N is equal to 100, and D is equal to 40. Now we can find Sn, sum of n terms or sum of 100 terms, as Sn is equal to n by 2 into 2a plus n minus 1 into d. We are going to substitute the values. This would be 100 divided by 2 into 2 times 20, because the value of a is 20, plus 100 minus 1 times 40. And now if we perform the necessary operations, this would give us 40 plus 99 times 40 again, and 50 times 40 plus 99 times 40 will give us 3960. 3960. And if we have 50, then this is 4000. And if we have 4000 times 50, then the answer must be 200,000. So this is sum of all those terms in first 1000 integers which are neither divisible by 2 nor divisible by 5.